Okay, here's a video for part 1 of your Unit 5 test review. Part 1 is just reviewing some exponent rules. For number 1, there's a couple ways you can do this. I like to think of this when I have a whole quantity inside the parentheses. Notice there's no addition or subtraction going on. And I have an exponent on the outside, is I can distribute that exponent. Now, let me make something clear. If this was 4x plus y squared, I would not be allowed to do this rule because there's a plus sign yelling at me, not letting me distribute that square. But since there's no addition or subtraction in number 1, it's all being multiplied, I can distribute that square to each term within the parentheses and make it 4 squared times x to the negative 6, I do power to a power, y squared. When I simplify that, that 4 squared has a positive exponent, is 16. It's going to stay in the numerator. Y squared has a positive exponent, and the x squared, or the x to the 6 moves to the denominator and becomes positive. Okay, if you want to think of that another way, you could think I'm taking 4x to the negative third y times itself. And then you would get the same answer. You take 4 times 4, which is 16. X to the negative third times x to the negative third is x to the negative 6, y squared. And you'll end up with the same answer. So 2 ways to approach that problem. Number 2, when I have a fraction, I'm going to be dividing straight down. So when I think of 20 divided by 12, 20 divided by 12 is, like, it's not a whole number, but let's see, 4 goes into both, so 5 over 3. M to the third over m to the 5th. Well, I subtract those exponents. 3 minus 5 is negative 2. So I have m to the negative 2, and negative 1 minus 4 is negative 5. But since those both have negative exponents, the n and the b have to move to the denominator. 5 over 3, m squared, b to the 5th. I guess I could write 5 in the middle to make it look a little more centered. That would be the answer. Now, another way to think about this is you have to know that the n and the b are going to be in the denominator. Look right here at the m's. The n in the denominator has more exponents than in the numerator. So if I were to cancel those, like if I wrote m out 3 times for m cubed and m to the 5th, 3 of those would go away, and then there'd still be 2 in the denominator. That's why it says m squared over here. Same thing with the b's. The b's are bottom heavy. There's more b's in the denominator, so they're going to be left in the denominator when you're finished. Part 3. Notice here that the whole quantity f to the 5th, d squared, is raised to the 0 power. Anything to the 0 power is 1, and that's just 1 times d to the 3rd, or 1 times 4d to the 3rd, which is 4d to the 3rd. That's it. And lastly, number 4, very similar to number 1. I'm going to distribute that exponent of negative 3 to the 3, the x, and 4. So it'll be 3 to the negative 3rd times x to the negative 18th over 4 to the negative 3rd. Now, since every single piece there has a negative exponent, they all have to flip, excuse me, locations in your fraction. So the 3 to the negative 3rd moves down, so does the x. Oops, sorry. But when they move, they become positive. So it's 3 to the positive 3rd, x to the positive 18th, and then the 4 to the 3rd becomes positive in the numerator. And then you can simplify. 4 to the 3rd is 64 over 27 x to the 18th. And that would be the answer. All right, that's it for part 1. Let me know if you have any other questions about exponent rules.